Okay, good day everyone. In today's class, we'll be talking about resolution of vectors. Okay, any vector can be resolved into two components which are perpendicular to each other. Perpendicular component is called the vertical component, and then the horizontal component is called the vertical component is called the vertical component, sorry, and then the horizontal component is called the horizontal component, as you can see here. So f is the vector, then the vector can be resolved into the vertical component and the horizontal component. The vertical component means the effective value of this force in this direction, and then the horizontal component means the effective value of this force in this direction. So if we are talking about the angle, if theta is the angle f mixed with the vertical, then the vertical component is f cos theta. But in terms of alpha, which is the angle f mixed to the horizontal, it is f sine alpha. So the same applies to the horizontal component. So it depends on where the angle given is. That will determine the formula to apply. So, but mostly, most questions you'll be coming across at this level would have the angle between the vector and the horizontal as alpha. So you are most likely to see f sine alpha for the vertical component and f cos alpha for the horizontal component. Okay, so if I have vectors like this, you can resolve vector 1 to its horizontal component and vertical component, vector 2 to its horizontal component and vertical component. And at the end of the day, you add all the vertical components. So if theta in this particular instance is the angle it makes with the horizontal, then the horizontal component that is along the x-axis for v1 will be v1 cos theta 1. That is the angle v1 makes with the horizontal x-axis. Now the horizontal here we are talking about is the angle it makes with the positive direction. If you draw a Cartesian plane, maybe something like this, sorry, there is a positive x-axis and there's a negative x-axis. So the angles we are interested in are the angles that these vectors form with respect to the positive side of the x-axis. This angle for this one, and then this angle for this one, not this angle. So it's very, very important to identify the angle in question. So sorry, and then if you do that, you use v1 cos theta 1 for the horizontal component of v1, v2 cos theta 2 for the horizontal component of v2, and so on and so forth. And at the end of the day, when you add them all together, you get the resultant along the horizontal direction. And then the same applies to y if the angle it makes is with the positive with the positive x-axis. Then you have v1 sine theta 1, v2 sine theta 2, and so on. And then when you add all of them together, you get the resultant along the vertical component. So theta 1, theta 2, theta 3, theta 4 refers to the angle vectors v1, v2, v3, v4 makes with the positive x direction. It's very, very important. So at the end of the day, if you want to get the magnitude of all the vectors at that point, you use this formula. R is equal to the square root of rx squared plus ry squared. And of course, since we are talking about vectors, it's also important that we talk about the direction. So the direction is the angle the resultant makes with the positive x-axis, mostly we use the positive x-axis. If you want to use any other direction, you need to specify. So it's given by theta is equal to tan inverse of ry over rx, where ry is the resultant along the vertical direction, and then rx is the resultant along the horizontal direction. Okay. So let's look at this example. A boy pulled a nail from the wall with a string tied to the nail. The string is inclined to the wall at an angle of 60 degrees. If the tension in the string is 4 Newton, what is the effective force used in pulling the nail? So maybe the diagram will explain what we're talking about better. So this is the nail, and then this is the string, and they attached in this form to pull this nail out of the wall. But you know that the force will be applied in this direction. However, the nail will come out. It means that there is a component of the force applied here in the horizontal direction that pulled out the nail. And then there is also a component that may bend the nail before it comes out. But that was not what the question is asking. It's asking for the force that wants to pull out the nail. So if we draw it like this, based on what we have said, you can see that the angle it makes is with the vertical. So the horizontal component in this particular case will be T sine of the angle, where T is the tension in the rope, the force in the rope. And then the angle, the component that want to bend the nail, the component of the force that want to bend the nail is Ty cos 60. So at the end of the day, we'll have, since the question is what is the difference, what is the effective force used in pulling the nail, we will not worry about Ty, we'll just calculate Tx. So Tx, just like we've written as, is T sine 60. So our T is the force on this rope, and it was given in the equation to be 4 Newton. So we'll put that into this formula and then find sine 60 with our calculator. We'll multiply both of them, we'll get 3.464 as the force pulling the nail out of the wall. Okay, let's look at the second question. 4 forces act at a point as shown. Calculate the magnitude and direction of the resultant force. So the angle for each force has been given. For 10 Newton, it is 30 degrees. For 12 Newton, it is 40 degrees. But the 40 degrees is the angle it makes with the negative x-axis. But the angle we are interested in is the angle it makes with the positive x-axis, like that is this angle. So we need to look for a way to find it. And of course, the 9 Newton force makes an angle of 90 with the negative x-axis. But the angle we are interested in is the angle it makes with the positive x-axis, this angle. We'll look for a way to find it. And then the same applies to the 15 Newton force, as this one. So let me remove all this annotation so that we can. So the 10 Newton force is obvious, makes an angle of 30 degrees with the positive x-axis, but the 12 Newton force doesn't make an angle of 40 degrees with the positive x-axis. It makes an angle of 40 degrees with the negative x-axis. So we need to find the angle it makes with the positive x-axis. Now, the angles on the straight line add up to 180. It means this angle and this angle will add up, and 40 will add up to 180. So if we subtract 40 from 180, we will get this angle. So that is what is done here. 180 minus 40 will give you 140, which happens to be the inclination, the angle of that 12 Newton force makes with the positive x-axis. And then a similar explanation will go for the 9 Newton force. The 9 Newton force is directly facing the vertical direction. However, we need to find the angle it makes with the horizontal x-axis, the positive x-axis, that is this angle. this very angle. So, but we already know that the angle on a straight line is 180, and then this angle that the remaining angle has been given to be 90. This is how you mark a 90-degree angle. So it means it is 180 plus 90, so which happens to be 270. So the angle that the 9 Newton force makes with the positive x-axis is 270 degrees. And then a similar explanation will go for the 15 Newton. So for the 15 Newton, we are interested in finding this angle, this particular angle. So that's the angle it makes with the positive direction. Somebody may say, but it makes 60 directly with the positive x-axis. We don't count it that way. You count it anti-clockwise. You count these angles anti-clockwise, not in the clockwise direction. All the ones we've been counting so far have been in the anti-clockwise direction. 15 Newton will not be an exception. So it's very important. So you already know that the angles at a point, if you add all angles formed at this point, you get 360. So, and then if you remove 60 from 360, you'll be getting this remaining angle. So that's what was done here. And then you get 300 degrees. So if we apply the formula and resolve each force into its horizontal direction and a vertical direction or component, this is what we have. Remember, the 10 Newton force has an angle of an inclination of 30 degrees. So, and then is with the x-axis. So the component along the x-axis is 10 cos 30, and then along the y-axis is 10 sin 30. Using calculators, you get this. And then 12 Newton force, 12 cos 140 will give us this, and 12 sin 140 will give us this. The 9 Newton force, 9 cos 270 will give us this, and 9 sin 270 will give us this. You can check all these figures out with your calculator. The same applies for the 15 Newton force. At the end of the day, according to the formula, you add all the horizontal components. This means summation of all the horizontal components will give us this. And then take note of the negative sign. You don't remove the negative sign when adding, because it counts as well. And then you add all the vertical components, you get this. So using the formula, when you take the square root of the square of the horizontal component added to the square of the vertical component, you get the resultant of all those forces you saw. So the resultant of all those forces that was given in the question is 27 Newton. So, and then to get the direction, remember the formula, theta is equal to tan inverse of Ry over Rx. So Ry we know is Ry is minus 9.277, and then Rx is this. So once we divide and then take the tan inverse, we'll get minus 20.1 degrees. But minus 20.1 degrees is negative angles. It's a negative angle. Most of the angle you will come across are positive angles. So you need to understand how this works. The idea is, let me pick a pointer from here. The idea is, when we measure an angle in the clockwise direction, it's always positive. But when we measure an angle in the anti-clockwise direction, that angle is negative. So that is what it means. But you can find the equivalent angle of a negative angle and the equivalent angle of a positive angle. Very important. So if you want to find the equivalent angle, sorry, I want to go back. If you want to find the equivalent angle for minus 20.1 degrees, you know that minus 20.1 degrees counted in the clockwise direction will be maybe something like this. So here will be minus 20.1 degrees. So it means that the angle if we are to count this same angle in the anti-clockwise direction, which is a positive way of writing angles, we'll have something like this. So if I can subtract, the angles at a point add up to give you 360. So that means I can subtract 20 from 360, I'll get the angle counted from the anti-clockwise direction. So, and that will give us 339.9 degrees. So this is the angle made by the resultants with the positive x-axis in an anti-clockwise direction. Very important. So you can try this on your own, and then we'll see.